The goal for today is to recall what it means to solve a system of linear equations and how to do it by graphing. The learning targets are specifically like the key things we go over in the lesson. So if you don't understand them by the end of the lesson, then that's when you verbalize that to me. So don't just come to tutoring and say, my grade is bad, help me. Tell me what you're struggling with. No headphones in, no cell phones out. But learning target for this lesson is that you can explain what we mean by the solution to a system of linear equations and where the solution is on a graph. You can explain what we mean when we refer to two equations as systems and use tables and graphs to solve systems of equations. I am recording right now. I'll link it in here just like always. I'll also include some lessons from last year, but the way that the lessons were last year were completely different from this year. So feel free to watch them if you're like, I need someone to just basically tell me everything straight up, like no problem-based learning. I'll link them in there and you can watch them if you want. Otherwise, it's just kind of more problem-based. You learn it by doing. It's not a bad method, it's just completely different from last year. So just keep that in mind. The puzzle piece will be lesson 12. We will not finish the lesson today. We'll probably finish it tomorrow. Give you some time, hopefully, fingers crossed, to do the puzzle piece. But also what is scheduled for tomorrow is a unit 2 mid-unit assessment. And that's per district. I'm supposed to give it after lesson 12. But it's over the same stuff as the quiz we just took also. So just, you know, it's the same stuff. That's your chance to redeem yourself and get a better score. So redeem yourself, get a better score. Maybe then I'll replace your bad score with this score. I have to give it per district. We'll see if there's time tomorrow. So I just want you to know it will probably be tomorrow. Wednesday at the very latest, but let's just go with tomorrow so that you're prepared. Bring your notes every day, something else. All right, so now we're going to start the lesson with a math talk. If you don't remember what a math talk is, what are usually the rules for math talk? It's just like a learning tool. What were the rules for math talks? Do I call out the answer once I have it? What do I do? You put your thumb up when you have the answer. And then I'll give time so we're going to see at least like half of you can thumb up. So some of you can't solve it. But also a rule was that you're not supposed to use like scratch words or a calculator. If you need to on this one, I don't mind, because why not? The other ones were easier in the past. This one, you might have to do a little bit of scratch work or some small calculations. But here's the question. Diego bought some raisins and walnuts to make trail mix. Raisins cost $4 a pound and walnuts cost $8 a pound. Diego spent $15 on both ingredients. Decide if each pair of values could be a combination of raisins and walnuts that Diego bought. So I'm going to show you the first one. Don't call out the answer. The answer should basically be a yes or a no. Is that a possible combination that he bought? Or is it not? And be prepared to defend it. You're in the wrong spot. And then, I really encourage you to use it once. I can do that somebody. And time for 40 minutes. You don't have 40-minute classes. If you end up needing more time, let me know. But just work for this fast period. All right, I'm looking for some. Is it a yes? Is it a no? Or did you look at the problem? It's not printed on your paper. After Aiden, you can go now. Other Aiden, sorry. That Aiden. All right, voices. Amari, is it a yes or is it a no? And why is it a no?
Since the walnuts on the ratings are $4, and since the walnuts are $8, so that's in the higher 1.5. That's rating plus 4.
Which gives me what?
If you have a plus, and therefore that's 16.
Okay, so 4 plus 12 is 16, which means he could not have spent $15 on those things. Did you guys follow that? Yeah. Okay, so 1 pound of raisins costs $4, 1 times 4. $8 for a pound of walnut, but we bought 1.5 pounds. Without a calculator, you could still do that. Because what's half of 8? So 1 of 8 would be 8, and then half of 8 would be 4. So that's how we're doing that without a calculator. So then 12 plus 4 is 16, which means that he did not spend 15, which is a constraint in this problem. It's in our math work. So first one would have been no. Now look at the second one. You don't call it out, just thumb up when you have an answer. All right, Allison, yes or no on the second one? Yeah. And why yes? 2.25 of the raisins is 9, you said? All right, and then what else? Is that it? The 0.75 of the walnuts gave me 6. What's 9 plus 6? That is correct. And that's what Diego said, right? So yes, that is a possible combination that it could have been. And because it's equals, it would have had to be exactly 15. So anything that if we multiplied it by the cost and it equals something other than 15 would not be a solution. Make sense? To do this without a calculator, you kind of reason with it. We have 2 full pounds of raisins, so what's 4 times 2? And then what's 0.25 of 4? 1. Like splitting it into quarters or something. It's a fourth. A quarter of 4 is 1, so that's where we can get the 9. And then 0.75, what's the equivalent fraction of that? 3/4, right? So if I could split the $8 that it costs for the pound of walnuts into 4, 3 of them would be 6. Or you can use a calculator and figure that out. But just because math talk, there's something without a calculator, that's how you could reach it. But good. Now we're going to take those same situations, and this is printed on your paper. This will be the first activity that we do. And to do this activity, you do need graphing technology. If you have a graphing calculator and know how to use it, I prefer you use that because that's what you can use on your ACT Inspire, not Desmos. But if you don't have the graphing calculator, then I'm going to push you to Desmos. because that's what you can at least use on your unit test. So pull that up, and it's supposed to be like within pairs. So if you're a trio, just work in your trio. If you're in the middle and there's like 4 of you, try splitting into pairs. Otherwise, some people are absent and go in your 3. It will be after someone. It will be after someone. So get your Desmos graphing calculator up. And the first thing you're going to do after, getting your calculator up and ready is to write an equation to represent the problem we basically just did, where the raisins cost $4 a pound, walnuts cost $8 a pound, and Diego spent $15 on both ingredients. But use X as pounds of raisins and Y as pounds of walnuts. Once you make your equation, graph it using Desmos or whatever graphing calculator you have. All right, what equation did you guys think best represents this situation? Looking for hands. Landon? Anyone think that that is incorrect at all? All right, good. And you should have used X and Y because that's what the instructions say. Just FYI, use whatever variables the instructions tell you to use. We've been talking about different kinds of equations or different forms of linear equations. What form is this in? If you guys remember. Remember what it's called? Remember what the formula was? No. Standard form is what this one's called. And that's what this equation is in. It's either going to be in standard form, the equations that you're making, or they might be in what other form? Slope-intercept form. So y equals mx plus b will be the other way. So either you'll have a situation that has a constant rate of change and a starting value, so like your slope and y-intercept, or you'll have it like this, where it's 2 things being multiplied by something, and maybe they cost different things, or you get different amounts from each. Either way, when you're making your equation, look for these patterns. It's probably one of these 2. So good. Once you have your equation, throw it into Desmos if you haven't already. So Desmos is super user-friendly. It will graph the line even if it's not in slope-intercept form, which is great. Because in elementary school, you probably had to rearrange it first before you would be able to graph it, like by hand. But now we have graphing calculators. So you could quickly do a few problems on your test. And you just have to know how to use your graphing technology. So that's what your line should look like. If I needed to identify a few things like my y-intercept, you would just have to know where to find it on the graph. What's my y-intercept? Or what's the definition of y-intercept? Where it intercepts the y-axis. And look, they even label it your x and y intercepts for you. But y-intercept is 1.875 for this graph. So that's when they buy 0 what? Zero raisins, because the x goes with the cost of the raisins, right? The y goes with the cost of the walnuts. Good. So now what we're going to do is using this graphing technology, we're going to fill in this table. So when there's 0 raisins bought, how many walnuts do I have in pounds? $1.875. That's what we just looked at. when x is 0, y is 1.875. So remember that your tables are usually sets of coordinates. So we said raisins are the x or the y. The x and walnuts are the y. So you can use your graphing technology either by zooming in, or I think in Desmos it's easier to just kind of like hold and drag. Where x would be 0.25 is somewhere around here. I would just hold down on the line and move. Might have to zoom in a little bit more. But I would hold down on the line and move until I have the x as 0.25, like that. So what's the y when x is 0.25? 1.75. So then you put that in your chart. That's printed on your paper. For these next two, what am I looking for? For this chunk of my table. I'm looking for the x's instead, not the x-intercept, but the x's. So when y is 1.375, and remember coordinates always go in what order? X comma y. So now I'm looking for when y is about 1.375. So on my line, look for that. We're looking for the y to be 1.375. Right there. What's the x when y is 1.375? 1. So then that's what I put in my table. So fill in the rest using your graphing technology. Don't call it out yet. But fill in the rest using your graphing technology. Maybe take turns so you can practice for yourself. And then think of other ways that you could solve this if you didn't have graphing technology, because we have solved problems like this before. I just don't know if you remember. All right, so what is the x when y is 1.25? Sorry, what was that? 1.25 also? So I'm gonna verify it by just typing in the coordinates. So this is something you can do in Desmos, but it doesn't really help you find the coordinates, if that makes sense. You would still have to do like the dragging on your line. But you can also type in coordinates and see if it falls on the line. You might have to zoom in to really see it. But yeah, it does. And then when x is 1.25, so is the y. So that makes sense. What about when x is 1.75? 1 you said, let's see. All right, looks like it's on the line, zooming in to make sure. And yes, so your y should be 1 when x is 1.75. And what about when x is 3? All right, let's see. It's down here. And it is 0.375. So you guys are correct. Was that easy? Simple enough? Can remember how to do it on a test and maybe cut down on some time? There are other ways to solve this problem though, algebraically. Do you guys remember how to solve this without a graphing calculator? What would I do? You would have to plug in whatever you're given. Because remember, that's my equation. So 4x plus 8y equals 15. And they're giving me at least an x or a y. So whatever one I have, I just plug in and solve for 15. I don't know why I put it in. So like, let's say I want to solve for when x is 0. Plug in a 0 for the x and solve for y. And see if you get the same thing as when we got it by graphing. What's 4 times 0? 0. What's 0 plus 8y? 8y. What's opposite of multiplying by 8? So then do that on each side. And when I put 15 divided by 8 in my calculator, do I get the same thing I got up here on the table, 1.875? I should, because everything on the line is a possible combination. And so here's just how to find it algebraically too. Questions on this activity? All right, so then next activity, which is also on your table. So here's a new piece of information. Diego bought a total of 2 pounds of raisins and walnuts combined. Now make an equation to represent that. So the new constraint, or like limitation, is that he bought 2 pounds of raisins and walnuts combined. With your group, come up with a new constraint. So asking you to write an equation to represent that the combined pounds is 2. What did you guys come up with? Anything? Supposed to be a little challenging, a little unusual, right? What did you guys say? Oh. 30. Yeah. Okay. So we times the original equation by 2. Is what they did. Anyone get something else? Now, so let me pick this apart, and it's a good place to start. Is the amount of money that Diego's spending changing? No, I told you. So we really shouldn't touch the first equation at all. The cost of stuff is not changing, but we need to make a new equation to represent the number of pounds that he bought, which is now having to be a total of 2. Any total should be next to equal signs, right? So if it's a total of 2 pounds, that should be next to an equal sign. Pay attention, this is important. This is like the important part. What did the X represent in our first equation? Pounds of raisins that they bought, right? What did the 4 represent? The cost. Do I care about the cost when I'm just counting how many pounds I bought? No. So I don't need the cost in my new equation when we're talking about the number of pounds. But since this is my pounds of raisins, I would need to combine that with whatever pounds of walnuts I bought, which was the Y. And what math word do we use, or math symbol do we use for the word combine? What math symbol do we use for combining stuff? No. Like when if your options are addition, subtraction, multiplication. Addition. Good. Adding. So this would be the equation. That's it. X plus Y equals 2. Because the X and Y represent the actual pounds. We don't care about the cost because we're just looking for the total pounds. Does that make sense? All right. Tomorrow we're going to start by having you graph it, this new equation, and filling out this table. So we'll save that for tomorrow. Make sure you read your notes every